Okay, so picture this. You're at the front of the line at Swig, that crazy popular soda shop. Your friends have sent you on a mission, and the order is big. You're trying to figure out what to get. A few of this, a few of that. Seems simple, right? Well, as we're about to find out, what feels like a simple choice can lead to some surprisingly huge numbers. So let's dive into the Swig Soda Challenge.
So here is the challenge for you. You need to buy 15 sodas for your group, and the shop has 6 different kinds available. Now, you can get any mix you want, all 15 of one flavor, a wild mix of all 6, whatever. So, how many unique combinations do you think are actually possible? Just take a quick guess.
The answer is a whopping 15,504. Seriously, if you tried to write them all down, you would be at that soda shop for a very, very long time. A number this big pretty much tells us there has to be a more clever way to figure this out. And, well, there is. So, how in the world do we get to a number that massive? We're going to use a surprisingly simple visual trick called stars and bars. It's this really clever method that transforms this huge, kind of confusing problem into something we can actually see and solve pretty easily. To get started, we're actually going to do something a little counterintuitive. We are going to completely forget about the sodas for a minute. Yeah, I know it sounds weird, but trust me, this is the key to cracking the whole thing. So let's represent those 15 sodas we need to buy as just 15 identical stars. Just think of them as little placeholders for the items we need to choose. Simple enough, right? Okay, now how do we divide these stars into our 6 different soda categories? Here is the absolute key. To create 6 separate groups, you don't actually need 6 dividers. You only need 5. Think about it for a sec. 1 divider splits a group into 2, 2 dividers create 3 groups, and so on. So for our 6 sodas, we need 5 dividers, which we'll call bars. So let's see exactly how this works. We have our 15 stars and our 5 bars. That's 20 symbols in total. All we have to do is arrange them in a row. Any stars to the left of the first bar, that's our first soda type. The stars between the first and second bars, that's our second type. You see where this is going, so take a look at the example on the slide. This specific arrangement means you ordered 2 of the first soda, 3 of the second, 1 of the third, 4 of the fourth, 2 of the fifth, and 3 of the sixth. And this right here is the big aha moment. We've completely reframed the problem. We are no longer choosing sodas. We are simply figuring out how many different ways we can arrange these 20 symbols. Every single unique arrangement of these stars and bars corresponds to one unique combination of sodas. Now, this visual trick is fantastic, but how do we turn it into an actual calculation? Let's unpack the formula that does all the heavy lifting for us. This is a classic problem in math called combinations with repetition. The formula looks like this: n plus r minus 1, choose r. Here, n is the number of types you can choose from, so for us, that's our 6 sodas. And r is the number of items you're actually choosing, our 15 sodas. That choose part is just a math function that tells us how many ways we can pick a certain number of items from a bigger set. Let's go ahead and plug our numbers in. N is 6 types, r is 15 sodas. And notice how this lines up perfectly with our visual trick. N minus 1 is 5. Hey, that's the number of bars we needed. And n plus r minus 1 is 20, which was the total number of spots for our stars and bars. You see? The formula is just a formal way of describing what we drew out. So, the problem really boils down to this. Out of 20 total positions, how many ways can we choose 15 of them to be stars? Well, that's 20 choose 15. And when you punch that into a calculator, what do you get? 15,504. And that is exactly how we got that massive number from the beginning. No more guesswork, just a really clever bit of math. Okay, but what if there's a catch? What if there are rules? Let's add a restriction to our problem and see just how powerful this stars and bars method really is. So let's say one of your friends is a die-hard Sprite fan. It's non-negotiable. You have to get at least 3 Sprites. How does that change our calculation? This is where a little something I call the pre-selection trick comes in handy. If we have to get 3 Sprites, let's just do it first. We take 3 Sprites and lock them in, put them in our basket right away. So now, instead of needing to choose 15 sodas, we only have 12 left to choose. Our n, the number of types, is still 6, but our r, the number we're choosing, is now just 12. We just solved this new, smaller problem. We just apply the exact same formula to our new numbers. So that's 6 plus 12 minus 1, choose 12, which simplifies to 17, choose 12. And the result is 6,188. Which makes sense, right? Adding a rule has cut down our number of options pretty significantly.
All right, one last challenge for you. This one involves some really clever reverse logic. I like to think of this as a real pro move for solving these kinds of problems.
What if the rule is the exact opposite? You can have 0 sprites, 1 sprite, or a maximum of 2 sprites, but absolutely no more than that. How many ways can we make that happen?
Now, you could solve this the hard way, the brute force method. You could calculate the combinations for getting 0 sprites, then do it again for 1 sprite, and again for 2 sprites, and then add all those numbers up. That's tedious. But there's a much more elegant way. Instead of counting what we want, let's count what we don't want and subtract it from the total. We already know the total possibilities, right? So what don't we want? We don't want any combination with 3 or more sprites. And here's the beautiful part. We've already calculated both of those numbers. We know the total is 15,504. And we just calculated that the number of combinations with at least 3 sprites is 6,188. So we just subtract the part we don't want from the total, and we get our answer, 9,316. So much faster. So, yeah, we've had some fun figuring out soda combinations, but this is way more than just a brain teaser. This way of thinking has huge real-world applications. This isn't just a math puzzle for a classroom. The whole stars and bars logic is at the heart of things like computer science, logistics, and network engineering. I mean, anytime you need to distribute identical things into different bins, whether that's computer tasks to processors or products to different warehouses, this is the fundamental logic that gets used. And that really is the big takeaway here. What seems like an impossibly huge and complex problem can suddenly become simple once you find the right way to look at it. By just reframing the problem from choosing sodas to arranging symbols, we made it totally solvable. And that's really the power of a good analogy, isn't it? It helps us see these complex issues in a brand new light. So the next time you're faced with some big, complicated problem, maybe ask yourself, is there a simple picture, a simple trick that can make it all clear? Thanks for tuning in.